Y'all want to do some math?
What's going on, guys? Welcome back. Today we're going to tackle the internet's most infamous viral math problem. You know the one, 6 divided by 2 times 1 plus 2. It looks like this. People can't seem to agree what this expression is supposed to evaluate to. There are debates about this all over the internet. If you go to any internet forum, there's probably a topic about this little expression here. And people argue about it really passionately, and I kind of like that, honestly, because a lot of these people that are arguing passionately about this expression are probably out of school, don't have much to do with math, but they still are interested, they're still passionate, they still want to learn. Learning isn't limited to some period of your life. We should always continue to keep learning. And that's why I went ahead and partnered with Skillshare for this video. Most of us have dormant interests, things that we tell ourselves we'd like to learn or do, but we get held back by resistance, and sometimes it feels like we don't really know where to start. We may even feel like this thing that we want to learn or do is somehow inaccessible to us, or that we need permission from someone to get started. I honestly think that simply having an interest or desire to do something is evidence enough that it's within our abilities. I don't think we'd have an inner desire to do something if it was something that was completely impossible for us. And that desire is, in a way, our innate ability seeking expression. Skillshare offers over 28,000 online courses taught by real professionals, completely removing any barriers to learning the things you want to learn and doing what you want to do. Whether you want to learn how to make sweet video edits, or learn to juggle, or become a master at card tricks, Skillshare's vast library will cover anything that you are being called towards. So punch resistance in the face, stop waiting for approval or permission, and start doing the things you want to do and learning the things you want to learn. Skillshare has offered us a free 2-month premium membership trial if you sign up with the link down below. Thank you, Skillshare, for sponsoring this video, and let's get started. Now, there are 2 common answers that people are getting for this expression, 1 and 9. First, I'll show you how people are getting 9. Right, so we have 6 divided by 2 times 1 plus 2. First, we should add the 1 and the 2. So 1 plus 2 is 3. We get 6 divided by 2 times 3. Next, we multiply 2 and 3 so that we get 6 divided by 6. And 6 divided by 6 is 1. So that gives us a final answer of 1. And here's how people are getting 9. So first, again, we'll add 1 and 2 so that we get 6 divided by 2 times 3. Now this time we'll divide 6 by 2. 6 divided by 2 is 3, so that we get 3 times 3, and 3 times 3 is 9. Now, which one of these is correct? I know you're waiting for me to cut to the chase and say which answer I think is correct. So first of all, a little disclaimer. This is a matter of convention. What this expression is supposed to be read as is a matter of convention, not mathematical truth. We cannot write a proof about how some symbols are supposed to be read. It's a matter of convention. That being said, the current standard convention, i.e. the convention that will be used in mathematical literature or programming languages and things like that, will give a value of 9. So this is the correct answer according to the standard convention, while this is not. This is wrong according to that convention. Now, what I find interesting about this expression is that it sort of capitalizes on every possible misunderstanding that someone could have about the order of operations that doesn't normally come up. And what I mean by that is someone could theoretically complete a bachelor's degree in a STEM field and get this wrong. They could go throughout all of their math education without this misunderstanding ever causing them any problems, depending on what the specific misunderstanding actually is. But I found that interesting. Like, it's a badly written expression. It's not ambiguous. You will get 9 if you follow the order of operations correctly. It's not ambiguous, but it is badly written. No one would ever write this way. And since it's so badly written, those misunderstandings of the order of operations will show themselves here and will lead to an answer of 1. So the point there is that if you're getting an answer of 1, it doesn't really say much about a lack of mathematical knowledge or intelligence or anything like that, because these misconceptions just don't normally come up. But I found this quite interesting that so many people were getting this wrong. So I decided to head on over to Austin, Texas and met up with Brain Gainz. And he and I went out in public and asked random people on the street to try to solve this problem. So I have a few of those results here. Hey, y'all want to do some math? Or you can write your final answer if you'd like. That's the most common answer we've got. But it's what?
You're supposed to do stuff in parentheses. So that would be 3, and then 6 divided by 2 is 3, but that's still in a parentheses, and that means time. So that is that it's not.
So 6 divided by 3. Now, the results were really interesting. They were pretty split. Majority of them said 1, but what we noticed is that most of the kids said 9. I think that has something to do with the fact that they are currently learning this and it's fresh in their minds. But yeah, most of our 9 answers were from children, which is something that was pretty interesting to us. Now, I'm guessing a few of you immediately disliked when I said it was 9 because you're holding on to the answer of 1 for dear life. Okay, so I'm going to address all of the reasons, or the common reasons I've seen that people will get the answer 1. So I'll leave timestamps below and you can at least hear me out. Now, although I cannot prove to you what the correct convention is, what I can do is offer a little bit of evidence that this is the standard convention and argue that it is a good convention and that it's better than a convention that leads to 1. All right, so the first thing I'm going to do to cover this topic is actually lay out what the order of operations is. So the first tier of the order of operations is addition and subtraction. That's the first tier. The second tier is multiplication and division. The third tier is exponentiation and roots. Now the final tier, parentheses, is not really a tier of the order of operations. It's more like a bypass to the normal order. If we put something in parentheses, we're saying, do these operations first in their normal order before the other stuff. So it bypasses the order of operations in favor of whatever you put in the parentheses. Now, here's something I'm going to say right now because it's going to come up later. The order of operations is an order of operations. You can tell by the name. What I mean by that is it is not an order of symbols. If you have the operation of multiplication, it doesn't matter if I represent it with a little times thing, or if I represent it with an asterisk, or if I represent it with a parentheses, or the Batman symbol. It doesn't matter at all. It's the order of operations, not the order of symbols. If the operation being symbolized is multiplication, it falls in the multiplication tier of the order of operations. The symbol being used does not matter at all. So here's what happens if you believe that multiplication has a higher precedence than division in this problem. So we have our 6 divided by 2 times 1 plus 2. You can say, okay, 1 plus 2 is 3, so we get 6 divided by 2 times 3, like so. And then multiplication comes before addition, so we do that next. We have 6 divided by 2 times 3 is 6, which is 1. Now, this is not the convention. Multiplication is not of higher precedence than division. They are of equal precedence. So we say work them left to right. And I will explain why we say work left to right. Now, it's not very enlightening for me to just say, no, that's not the order of operations. Multiplication and division are of equal precedence. So what I'm going to do is I'm going to justify it by explaining the motivation behind the order of operations. Although the order of operations is a convention, a choice that we've agreed upon on how to read expressions so that we can understand each other, the convention that we've chosen wasn't arbitrary. It's there for a reason. It's based on innate properties of the operations themselves. And it's a good idea to have our convention based in something innate about the operations because that will lead to nice visual expressions of certain properties that are innate to these operations. So in a nutshell, here is the motivation behind the order of operations. We look at whether or not an operation can be expressed in terms of some other operation. If it can be, they are of the same precedence. As one can be expressed in terms of the other, it's not really a new operation in a sense. So let's start with the addition tier. If we have two numbers A and B, we can add them. A plus B. So that is our addition tier. Now let's move on to another operation. Let's try subtraction. The question is, can I express any subtraction in terms of an addition? If I can, then it will go in the same tier, as they are fundamentally the same operation. In other words, the operation of subtraction does not add any new information to the algebraic system that we're in. That might be a little abstract, but that's really the point. So the answer is yes. Any subtraction can be written as an addition. For example, if we have A minus B, for any two real numbers, A and B, or complex numbers or what have you, we can write that as A plus negative B, always. So subtraction can be written in terms of addition, always, so they go on the same tier in the order of operations. Now let's move on to the next operation, multiplication. The question again is, can we express multiplication in terms of addition? If we can, it goes on the same tier. Well, the answer is sometimes we can. We can do this when one of these numbers, A and B, are a natural number. For example, if A is a natural number, then we could write this as B plus B plus B dot 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 plus B, where this is happening A times. But if neither A nor B are natural numbers, then we cannot in general express a multiplication in terms of addition. So you can think of multiplication as being a generalization of addition. When it comes to multiplying natural numbers, it can really be expressed in terms of addition. It doesn't add any new information. Side note, this is also why abelian groups and Z modules are the same structure. Anyway, when we generalize this idea of a repeated addition to allow for a product of two non-natural numbers, for example, we move up a tier. So we have a new tier, and that's multiplication. Now we move on to the next operation, which is division. So of course, division does not fit in the addition tier. So we'll ask, does it fit in the multiplication tier? Can any division be expressed as multiplication? And the answer is yes. It is multiplication by the multiplicative inverse, just as subtraction is addition by the additive inverse. So we're still in the same tier. Now we'll move on to yet another operation. Let's try exponents. We'll raise a to the bth power. The question is, can this be expressed in terms of multiplication? And just like before, the answer is sometimes. We can do this whenever b is a natural number. So if b is natural, this is equal to a repeated multiplication, a times a times dot 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 times a, and this is done b times. But to get exponentiation in general, we need to generalize, and so we go up a tier in the order of operations, and we get the tier of exponents. And finally, we'll look at roots. So spoiler alert, roots do not fit on this tier or this tier, as roots cannot be expressed in terms of addition nor multiplication in general, but they can be expressed in terms of an exponent. That is, if we have the bth root of a, that is equal to a to the 1 over b. So roots belong in this tier of the order of operations. Now, how do parentheses fit into all of this? Well, again, parentheses is not really a tier like the other tiers. It's more of a bypass to the normal order. Now, if two operations are on the same tier of the order of operations, in other words, they have the same precedence, we say work from left to right. So if we have something like that, we say work from left to right. Now, that seems kind of arbitrary. Why should left to right matter? And the truth is, it doesn't. They can actually be done in any order, but you have to preserve which number is being subtracted or inverted and which number is being added. The fact that we put the symbol to the left of the number is why we say work from left to right. It guarantees that you'll do this correctly. But provided that I preserve the operations to the number, I can do it in any order. So the normal way to solve this would of course be 6 minus 2 is 4, plus 1 is 5. Okay? If someone thinks that addition comes before subtraction in the order of operations, they will get this wrong. They'll say something like 6 minus 2 plus 1. Add first, we get 6 minus 3, which is 3, and that is incorrect. But if we preserve the fact that 2 is being subtracted and 1 is being added, we can do it in any order. For example, this is the same as 6 plus 1 minus 2. That's 6 plus 1 is 7, minus 2, which is 5. So we say left to right basically because it guarantees that the operation will remain associated to the number it was originally associated to. So you can do them in any order, just preserve which number is being subtracted and which number is being added. We can also apply this idea to the problem we're actually discussing. Let's see what happens if we rearrange 6 divided by 2 times 1 plus 2, but preserve the operations. Now, according to the standard convention, this is 6 divided by 2 times 1 plus 2. It is not 6 divided by this stuff. I know it looks that way because the symbols are close together, but that's totally irrelevant. So bearing in mind that we are dividing by 2 and multiplying by 1 plus 2, we can do this in any order we'd like. So let's switch it up. Instead of 6 divided by 2 times 1 plus 2, let's say 6 times 1 plus 2 divided by 2. Can I do that? Yes, I can, because I preserved which number is being associated to which operation. And 1 plus 2 is 3, 6 times 3 is 18, 18 divided by 2 is 9. And we could do it in any order we want, ever. So we could even do something like 1 plus 2 divided by 2 times 6. That's gonna work too. 1 plus 2 is 3, 3 divided by 2 is 3 halves, times 6. 3 halves times 6 is 18 over 2, which is 9. So if two operations are of equal precedence, you don't have to work them from left to right, you just have to preserve which operation is associated to which number, and working them from left to right guarantees that you will do that. We just tell people work from left to right because telling an 8-year-old, no, you just have to preserve which operation is associated to which number, that might not work very well. Now, the next common misconception I see, and this one's a lot harder to fix, people really hold on to this, it's the belief that 2 times 3 is somehow different than 2 times 3. As in, this has a higher precedence somehow. So like I mentioned earlier, the symbol being used to express an operation is absolutely irrelevant, completely meaningless. It's just writing. The operation in both of these cases is multiplication, so it goes in the multiplication tier of the order of operations. There's no asterisks in the order of operations saying, depending on what symbol is being used. It's just the order of operations. Bottom line, these two things are completely interchangeable. Now, I hear a lot of justifications for believing that this is of higher precedence. One of them is that this is a parentheses, so it belongs in the parentheses tier of the order of operations. And this is false. Again, the parentheses are a bypass. Do the operations inside the parentheses first. It bypasses the normal order. But the fact that we are expressing multiplication with a parentheses, absolutely irrelevant. There are no operations to do here. This just means 2 times 3. Now, another thing I see people do when it comes to justifying this belief that this multiplication symbolized with the parentheses is special is that they will call this little block of symbols here something. They will give it a name, such as this is a single term. That's one I hear often. I've heard entity or unbreakable bond of fellowship. I haven't actually heard that. But in any case, all of these are manifestations of the same thing. These two numbers are really close together, so we want to believe that they're associated in some way. It's a completely visual thing, and the visuals are irrelevant. We have to ignore, in a sense, what it looks like. The fact that these two are closer together than these two doesn't mean anything. It's just an appearance. So the correct way to proceed from here would be, okay, division and multiplication, which this totally is, are of the same precedence, so just work from left to right. So 6 divided by 2 is 3. 3 times 3 is 9. Now, the third misconception that I commonly see that will lead to an answer of 1 is using the distributive property, although incorrectly. And side note, this also leads to a less common answer, but I still see it sometimes, of 7. So let's apply the thought process of using the distributive property to get either 1 or 7. So we have our 6 divided by 2 times 1 plus 2. Now the distributive property states that if we have A times B plus C, that is equal to A times B plus A times C. So if we apply the distributive property, we see that this matches up precisely with this. So if we apply the distributive property, we can replace this with the corresponding expression here. So we have 6 divided by, apply the distributive property, and here's where we get 1. Apply the distributive property, and we get 2 times 1 is 2, plus 2 times 2 is 4, and 6 divided by 2 plus 4 is 6. So we get 6 divided by 6, which is 1. And the people that get 7 do this. All right, so from here, we'll apply the distributive property again, so that we get, replacing this with the corresponding expression here, 6 divided by 2 times 1 is 2, and 2 times 2 is 4. So we get that. And 6 divided by 2 is 3. And 3 plus 4 is 7. Now I actually think this is a bit more reasonable. They're both incorrect, but this is more reasonable than the 1 answer here, because why are we putting this in a parentheses? You know, why are we grouping these? Because it gives us the answer of 1 that we want. I don't see why we would group these, given that this is what the distributive property says. So I don't see why that grouping is there, giving an answer of 1. The people that get 7 this way, at least they're not grouping them. So that's a little more reasonable to me. But both of these are incorrect, and here's why. In the distributive property, this little guy A does not mean a symbol or a number. It means whatever is being multiplied by this sum here. A, B, and C can be full expressions themselves. So when we apply the distributive property, we do not take A to be the single symbol that is next to the parentheses. We take A to be the other factor of the product, what is being multiplied by this sum. And the answer to that is 3. 3 is being multiplied by this sum. And how can I justify this? Well, the distributive property is a property about multiplication. I multiply A by this sum, and I get this result. So applying the distributive property is the operation of multiplication, and therefore it belongs in the multiplication tier of the order of operations. I am multiplying. So if I opt to leave the 1 plus 2 alone and not add them first, and it's okay to do that because nothing outside of that parentheses is competing for precedence with it. So we will proceed by leaving the 1 plus 2 as is and starting outside. We would have the division first, as it is of equal precedence of multiplication, which is what we're doing when we apply the distributive property. You apply the distributive property, you are multiplying. This action does not transcend the order of operations. It is one of the operations, it's multiplication. So first we divide 6 by 2. 6 divided by 2 is 3 times 1 plus 2. Now from here we could proceed like last time, add 1 and 2, we get 3. 3 times 3 is 9, or we could apply the distributive property. What is being multiplied by this sum? 3. So 3 is A. What are the two summands? 1 and 2. So by the distributive property, this must be 3 times 1 is 3, plus 3 times 2 is 6, which gives us 9. So if one wanted to apply the distributive property to this expression, I don't know why you would do that, but you can, because it's a fact. This is the correct way to do it. So that's the explanation, but why is this convention to be preferred? Well, two main reasons, which were mentioned in said explanations. First of all, the order of operations is based in innate properties of the operations. Putting multiplication of higher precedence than division would be sort of arbitrary and not based in an innate property of the operations, like leaving them on the same precedence is. Secondly, this convention has fewer exceptions, or essentially no exceptions. If you're this operation, go here. We don't care what symbol is being used. If you're this operation, go here. No exceptions. I don't want to have to look up what an individual symbol means and what its precedence is, because my precedence is not a precedence of symbols. It is a precedence of operations. So fewer exceptions is a good thing. Now, could I somehow have the audacity to believe that I have single-handedly ended this legendary internet debate. No, I don't. I don't think I made a slight dent in it. I'm pretty sure there's gonna be people yelling at me in the comments about how dumb I am and how I got it wrong. And I wouldn't have it any other way, because this is a literal legend of the internet. I've seen really great explanations behind this on YouTube and online, and yet it continues. The debate rages on. Anyways, that's gonna do it for this one. This video was a lot of fun. I hope you guys enjoyed. If you think I'm totally wrong about this, don't forget to leave your comment down below saying how terrible I am and how I should delete my channel or whatever. If you're new here, be sure to subscribe, and I'll see you guys in the next one. Keep making those brain